So today we'll start special cases of Gauss theorem. Last time we have studied Gauss theorem, so some special cases are left. So today we'll do special cases of Gauss theorem. We know that because Gauss theorem phi is equal to surface integral of electric field is equal to net charge enclosed over epsilon naught. This is the Gauss theorem. So now first case is if the closed surface does not enclosing any charge, mean that is Q is equal to 0. Suppose we have this closed surface and this surface does not enclosing any charge, mean Q is equal to 0. Then electric flux is equal to 0 upon epsilon naught, that is equal to 0. Because this is a net charge enclosed by the Gaussian surface, so we will take this closed surface as Gaussian surface, and this Gaussian surface does not enclosing any charge, that is Q is equal to 0. Then flux coming out from this closed surface is equal to 0. I think this point is clear. Come to second case. Special case second is if a closed surface containing two equal and opposite charges, that is dipole. You know that dipole is a system of two equal and opposite charges, minus Q charge and this is a plus Q charge. If this system is enclosed by the closed surface, let us suppose we have this closed surface enclosing two charges, minus Q and this plus Q charge. So you know that due to this positive charge, electric field lines will go out from this closed surface, will move out from this closed surface, and due to this negative charge, electric field lines will converge, terminate at this negative charge. They will terminate, and from this charge they will go out. So net electric flux, that is equal to 0. Number of electric field lines going outside is equal to number of electric lines coming inside. The net electric flux is equal to 0. You see, phi is equal to net charge minus Q plus Q divided by epsilon naught, that is equal to 0. If suppose this charge, let us take example, let us suppose we have this closed surface and enclosing charge is plus 2Q and minus Q plus 3Q charges. Then total electric flux coming out from this closed surface, you know, that is plus 2Q minus Q plus 3Q divided by epsilon naught, that is equal to 4Q upon epsilon naught. By knowing the value of charge enclosed by this surface and epsilon, that is constant value, we can calculate flux coming out from this closed surface, because this is the net charge enclosed by this closed surface. This point I think clear. Now come to third. Net electric flux through a closed surface is directly proportional to the net amount of the charge enclosed within the surface, but independent of the size of the closed surface. The net electric flux that depend upon, you know that phi is equal to Q upon epsilon naught, very clear from this expression. This electric flux depend upon the magnitude of this charge, this is the constant value, and this one line is added but independent of the size of the closed surface. Suppose we have this size of the closed surface and one is this size. This surface enclosing plus Q charge, this is also enclosing plus Q charge. The total electric flux, that is equal to this same, does not depend upon the size. Suppose we have this much size of surface enclosing the charge plus Q and this much size enclosing charge plus 2Q. So from this surface, flux is equal to Q upon epsilon naught, and from this 2Q upon epsilon naught, depend upon the charge enclosed, independent of the size. I think this point also clear. Now fourth point is net electric flux due to a charge lies outside the closed surface is 0. Now in this case, this is the closed surface, enclosing no charge, Q is equal to 0, enclosing no charge, this surface enclosing no charge, but charge is lying outside the surface. Let us suppose plus Q charge is lying outside the surface, so electric lines will come out in this way. They will pass through the closed surface and coming out. You see, these are the electric lines coming, entering from this side and coming out from this side. These are the electric lines. These are the electric lines. So number of electric lines entering the surface is equal to number of electric lines leaving the surface. So net electric flux is equal to 0. Number of electric field lines entering the closed surface is equal to number of lines leaving the closed surface. So phi E is equal to 0. I think all the points are clear. Thank you.